Hello, everyone, and welcome to the second episode of the webinar about how to create a robotics product in 3 weeks when you have an idea. So I would like to just to confirm that you are listening to me. So please let's check that everything is working. Say something on the chat. Let's see if here on the chat. Let's check. Okay. Okay, great. So everything is working. Yeah. Great. So what is this webinar about? So it's the second part, as I mentioned, from the previous one that we had the last week. And in this week, we are going to actually see how to select the software that you are going to need and which part, to decide which part you will have to build in terms of software. Okay, so let's go step by step. And also, we are going to see how to select the hardware parts also. So let's go. And then the goal of this webinar, as in the previous episode was stated, is to show you how to build a robotics product in a very, very short time. So from your idea, then reusing as much as possible what it's available there in the world. And in episode 2, we are going to see the final Barista specification. And we are going to select the parts for your project. And we are going to simulate the robot and the environment in which the robot will have to work. And this is basic for this episode to generate the simulation, because before we build anything physical, we have to test that all the algorithms, all the software is working on the simulation. This is crucial step in order to go fast. And then we'll start developing some software. So how do we do all this? Let's see. And then the idea is to have the product ready in a record time with just a small part of development and reusing as many parts as possible. And also, we want to have it easy to maintain. That's why the reusing parts makes this easy to maintain. Related to me, so I'm Ricardo Tellez, I'm the CEO of The Construct, and I'm going to explain you all this based on our experience that we have developed by creating a product that we call Barista. It's the robot that serves the coffee to the tables. And we have used this outline, this number of steps in order to develop this product in just 3 months. Actually, I would like to be more concrete. And this project was actually built by 2 students. And those students, they didn't have any previous knowledge about robotics, nor any previous knowledge about ROS. So that's also a very, very important feat that they have achieved to build that product from the idea to the product that is working at the cafeteria in only 3 months. Okay, in that case, it was 3 months. The webinar is in 3 weeks because we are explaining this in 3 weeks, or the whole process. So let's go. First, I would like to start by sharing with you the Barista project outline. And here, there is a small error in the slide, but it's okay. So here, if you follow the previous episode, you had several parts that you have to take into account and that you have to decide related to your project. For example, we have, I put some homework to the previous attendant, to the previous webinar, so that you have to create the project outline for your specific product that you want to create. And I have received also some projects by Biorail and also by Abhijit. And I have reviewed them, and they have followed the structure that we are going to see in this slide. One of the parts is that you have to put into the project outline are the robotics parts. So which parts you want to use? But let's wait until we see this, to see this until we got the previous part. The first part that you have to put into your project outline is the task to solve. In our case, for the Barista project, is how to bring the drinks to the tables at the coffee shops. So this is the task that we want to solve. Okay, we have this idea clear. Then once you have this, you have to decide the constraints. In our case, again, for the Barista project, we decided that the robot has to work on a flat surface, and it will only have drinks that are served in cups, and that the tables at which the robot has to go, they have to be fixed positions, fixed locations. Great. The next thing are the robotics parts that you can see there. So what is the minimal physical structure, and including sensors, including actuators, including computer power, that you will need in order to solve that task? That's where you had to think about. And also you had to think in terms of parts that already exist, that you don't have to build. At least you should reduce this amount of parts that you have to create, that you have to build, to the minimum amount. In our case, and I propose this to everyone, also that follow the same thing, is we had to build no physical parts. So we build the whole robot by using all parts that already exist, except some others that you will see beneath this list of robotics parts. So what were the parts that we are going to use for the Barista robot? The mechanical structure, that is what provides the shape to the robot, and also the differential drive, the machine that moves the robot around, also the batteries and the handling of the battery. So all of that is already built. You can buy something that already provides this off the shelf, working with ROS already. So that's what we selected. That's the Turtlebot. Then the sensor laser. So we needed a laser in order to create the maps, navigate, avoid obstacles, and detect things. So that's the laser that we used. And as actuators, we needed no actuator because the robot just has to move from one place to another. And as a CPU, we selected the Intel NUC, that it's a computer, a small computer. Then after we decided this about the robotics part, we had to decide about which decorative stuff, because if you build a product, it's not only the functionality that matters, but also how it looks, your final product. And here is where you have to select things. For the Barista robot, we needed the covers for the top and bottom, then some stickers in order to to get the image of the place where the robot is going to work at, and some attrezzo, bow tie, in order to make it more like a gentleman or something like that. Great. So and this is the final design that we created from the graphic designer. So we use a graphic designer in order to accommodate all that stuff into a nice looking product. Okay, so this is the way that the graphic designer saw it. It doesn't mean that this is going to be the final version. As you can see, that the final version differs in some case, just for as always, that happens always, because after the graphic design, you have some modifications, practical modifications that cannot be performed, and that they are. So we believe that can be done here when you are defining the graphic looking of the robot. But then once you move to the practical things, then things change. So a little bit, but it's okay. That's normal. The important thing is that you have a design and that you try to follow that. Okay, so that's the final product. Great. So here I have shown you the Barista project outline. Okay, so now once we have this, that's to create this project outline was the homework for you last week. So I hope that you have already done it. I am giving a thumbs up to Biorel and also to Abhijit for having done it and sent to me for review. And so no, based on this, we are going to move into actually selecting the robot parts. For that, I suggested to use this online store. You can use any other if you want, but this one is very good. As run by some friends of mine. I don't have any commission of this, so you don't worry about that. But I like it. The people that is running, very professionals, and the idea of selling ROS components is the first one in the world. So I think it's quite interesting. So let's go to this website. If you press here, let me show you because I have already selected here. So what's the thing that we need? Based on this slide that you have here, so you have to select the robotics part. Okay. So first, we need a mechanical structure. This structure depends on your project. In our case, we needed a turtlebot, but you can think here, if you go to this website and check for the robot, you can see here that there are different types depending on your application. Okay. In my case, it's a mobile robot, and this is in Spanish. I think we can change it to English so you can see it better. And in our case, yes, mobile robots, here it is. You have the different types, and then again, it depends on your application. But everything that you buy here, it's running ROS on top. So in our case, we decided to take this one, the Ep.2. It's for this price starting. Maybe we could have opted for this one, but we also wanted to have the whole structure, the sides and the table, in order to be able to accommodate the coffees and have everything already prepared. So we can move faster, and it's only 150 euros more. So it's worth for the speed. In your case, you should select which one of those will fit your needs. It depends on what you want. So as you can see, there are so many different types of mobile bases. You don't have to build your own. I'm sure that you can fit any of those in your project. So the next thing that you have to select is the laser, the sensor. In our case, is the sensor laser. We selected that one, but as you can see, you have here many other different types of lasers. So you should check which one is the one for you. In our case, we selected this one based on price and also based on the fact that it can be powered with the USB of the computer. So we don't have to add any extra electronics for powering the laser. Another one that we have fit on this is this one, but this one came later after we started the project. So it's working. I have tested afterwards, and then it works quite well, and it's less expensive, as you can see. So in case that you are doing something similar to our project, it's okay if you use this LiDAR. And then you just have a look around and then check it. You can see that here there are other types of components like cameras, actuators, GPS, IMUs, power sensors, etc. So you can have it. And again, it's in English, but it's in Spanish, but you can switch to English, no problem. And then finally, let me just switch to English. So we got it. Yeah. So finally, we have some accessories for the Turtlebot 2. And here you can see different things that you can add to the Turtlebot. Then we selected this computer that is powerful enough for what we wanted to. Then another thing is that, for example, here we see a docking station. So should we add this to the product? This is my question. I would like to hear your answers on the chat. Should we add this? Because what do you think? Because if we add this, the docking station, then the robot will be able to dock itself and then recharge by itself. I think that this is very nice feature. But what do you think? Should we include this into the project? Tell me something on the chat. I'm here listening. And in the meantime, I'm asking some questions here that says by Biorel that says the Turtlebot LiDAR have some blind spots due to the 3 metallic rods. And the answer is yes, but they are very, very small blind spots. So what you do is that you take, how we did it, is we take the laser and then we just filter the measures on the rays that are colliding with the metallic rods. And that's all. Yeah, you lose some rays, maybe 5 rays in 700. So it's not a problem. It's not a problem. So what about the answer to the question that should we add this docking station? No one? Yeah, Abhimanyu. Yeah, Abhimanyu says no. Wait until version 1 is ready. That's very good, Abhimanyu. Yeah, and Jasprit also says no, because that's for long-term development. Right now, we need it only to work as a first product. Yes, the dock extension is cool. In my case, I haven't used it. Vihajasti says buying a docking station totally depends on the environment. Yeah, we should add docking spot, Shubham. Okay, so I mean, from the philosophy that I'm explaining here about creating products, robotics products very fast, no, you should not attempt that. That's a waste of money. And of course, most important, it's a waste of time, because you will have to build some things to make the robot, some software things to make the robot dock by itself. And so that's sometimes that you cannot, even if you don't know if this product is going to be useful for something, or if people would like to buy that product. So you will be wasting your time before testing. You have to go very fast to testing. That is why. So then we'll wait this, and then for version 2, maybe we'll decide to add the docking station. Maybe. Okay. So that's how we selected the components for our robot, and how I recommend you to use it. If you need some component that is not there, just go to the internet and check it wherever you can find it. The problem is that you will have to be sure that there is a ROS, a driver for your product. This is not always the case. So you have to be sure, and then that's it. If your product is so specific that it requires this, then just go ahead and look it. So my advice is that you always try to simplify and use things that you know that are ROS compatible and that they already built. You don't have to do any interface to those. Okay, great. So we have selected the parts. Now let's go and select the software. And the software is the part that is going to allow the robot to do whatever we want it to do. And for that, we are going to use ROS, as I mentioned. Why? Because most of the things are already done. That's the answer. And because most of the things are somebody else is maintaining it. So you don't have to maintain a ROS, your navigation program, your manipulation program. So that is why we use ROS. And also because it works very well. So I like ROS very much because it's very good piece of engineering, software engineering. But anyway, so how do you decide which ROS part you have to select? Where do we start looking? Because ROS is so big. So we have classified here the software of ROS in several categories where you can go and look faster for it. And I would say that for any robotics project, like the ones that we are designing here, you will only need the following categories. First, you will need the robot moves around. That means that you will have to use ROS navigation software. There are some packages in ROS that are dedicated to ROS navigation. And that's where you have to look when you need the robot to move around, like in our case. So in other cases, you will need your robot to perceive stuff. Maybe the robot needs to perceive the tables, the people, the faces, the objects, recognize them, etc. All that goes inside the ROS perception software category. So you will have to look for this kind of packages inside ROS. Another one is when the robot needs to interact with the stuff. So imagine that the robot your product has to grasp things. Maybe it's a garbage collector. It's a robot that grabs some stuff that is on the ground and then puts it on the bin, on the trash bin. So that's manipulation software or manipulation packages of ROS. Those are the ones that allow the robot to manipulate stuff. Then you will need some software that orchestrates the whole behavior of the robot. So, for example, if you have a robot that needs to answer the door, then you will need to have to create something that is called state machines. The state machines indicate different states that the robot has to be and how to change from one state to another. So if the robot has to answer the door, then the robot first will be waiting for hearing the door to be knocked. Then once the robot has heard the knocking of the door, then it changes state into navigating until the door. So the robot will go moving until the door. Once it reaches the door, then the robot has to open the door. Then it will open the door. And finally, it will say hello to somebody, follow me, whatever. As you can see, those are a series of states. So how to change from one state to another, etc., all the conditions, how to go back to the initial one, etc. This is handled by state machines. And ROS has a very nice software that is called SMAT, that it's about creating state machines that work with ROS. Next thing that usually works in those kind of projects is to integrate your robot with the web. So your programs need to talk to some web thing, web page, web application, whatever. For that, you will need to use the ROS bridge. It's the software that allows you to connect web applications with ROS and talk to each other. This is very convenient. For example, if you want the robot to be able, you can direct the robot, send commands from a mobile device, like a tablet or a phone, for example. And then have put also this as a voice interaction. Maybe your robot will need to speak or understand some vocal commands. I don't recommend to build products that require to understand vocal commands because usually it doesn't work. It works very badly, but it could be for some specific applications in quiet environments or something that you have very, very control of the speech. Maybe the people is talking through a mic or that is on the headset or something in that case. Or the robot needs to talk, to say something. That is good. If you want the robot to make it talk, it's good. But only if it is required for the task. If it's a nice to have, then it will have to wait till version 2, okay? Okay, so far so good. Then let me just switch a little bit to the chat to see if there is any question. And we continue. Okay. Then let me see. Then it was a trap, hey, IRL, about the question for the docking. Yes, it was a trap, just to hear if you are listening and you are paying attention. Then viral indicates how much space of HDD on the Intel NUC is advisable of hard disk, you mean? Well, that depends on your application. I cannot tell you. It's you need to install ROS, your application, and whatever extra that you would like to have for logs or for things that generate that the programs generate or whatever the reason. But as less as possible, I would say. Just always in order to minimize. Okay, there is no other questions here on the chat. So I'm going to switch again to the slides. Let's go. So we have, in the last slide, I shown you the categorization of the ROS parts. So you have to be sure what your robot needs from all those parts, and then go and look for the software of ROS, for the ROS software that provides those parts. So in case that you don't know about ROS, I would like to recommend you the Robotic Night Academy. That's the academy that we have built at the Construct for teaching ROS very fast. If you go to this address, so you will see that it's, let me just click on here. So we have many courses that will teach you ROS basics, perception, that we have talked about, navigation, manipulation, navigation in 3D, etc., controlling, etc. So also how to program already existing robots with ROS. So have a look in case that you don't know enough how to select your ROS packages, which parts of ROS can solve your problem, and let me know what it's about. So then, related to continuing on this, so once you have selected the ROS packages that you need, and you know how to launch them, how to run them, then you may need to adapt. So you may need to create small modules of software in order to adapt the generic solution that ROS is providing to your specific solution. So you should aim to develop as less adapters of this as possible, okay? As simple as possible. But this is something that usually is unavoidable because, of course, your product has different requirements, and ROS is a generic solution for everyone. So you will need to that, but aim to create as less as possible. In the case of the Barista software, so the robot needed to move around. So for that, we use the ROS navigation software that is called the ROS navigation stack. We also needed interaction with web. Why? Because we wanted the person who prepared the coffee has to indicate the robot which table has to go and serve. And for that, we decided that very easy solution would be to provide the person with an iPad with all the tables, a map of the cafeteria, and then the person just press on the table in the cafeteria map, and then the robot goes there. That is done with the web page shown on the iPad. And for that, we need the ROS bridge. The ROS bridge is the software that captures this touch of the person on the iPad and then converts this into a topic call. And that's all. And then once the topic call is there, we have our adaptation software that will connect that. So the adaptation software that we built was first the web page that shows the tables and allows the person to indicate which table the robot has to go. And then a small node that connects to ROS. So it uses ROS bridge and then gets the number of the table from the web page and converts it to a goal for ROS navigation. Okay, so that's basically how it works, our adaptation software. Okay, so far so good. So we have learned a methodology for selecting the hardware that we need, and also to select the software, the ROS software that we need, and also to identify which parts we need to create extra software for adapting to already existing ROS software. Now, let's go and the part fourth. Once we have this, we have to test everything on the environment, on a simulated environment. So the idea is that you test everything prior to going into the real robot. So at this point in time, we have selected what we would like to have in our robot, but still not bought. Why? Because we are going to wait until we have our software, our solution working on the simulation. It could happen that whatever you want the robot to do is not possible to be done in real life because whatever the reason that we cannot think about now. So you have to test on the simulation and see that is in principle, it's possible to build that solution, at least on the simulation. Then you will see that sometimes you assume some things on the simulation that doesn't happen in the reality, then you will have to adapt your solution in the simulation until it's possible to make it work on the simulation, and then readapt your product. For the simulation, we need to simulate two things. First is the simulation of the robot, and second, the simulation of the environment in which the robot will be working. And for that, I recommend you that you use the ROS Development Studio, that you can go and get it an account for free there, and there you will have already many robots simulated, many environments, and you don't need to install anything on your computer. So you can just use this and go to that webpage and start developing and testing, and the simulations are there. And let me give you an example of the simulation that we built for Barista. Well, in this case, first is the simulation of the robot, okay? So for the robot, we know we have the Tartarbot. So the simulation of the Tartarbot already exists. We didn't have to build anything. So it may happen that in your case, you will have to build something, but some small parts or modify existing simulations. If that is the case, then you have to. But for the Tartarbot, in that case, it already existed the simulation. So we just took it, the simulation of the robot, okay? This simulation, this robot simulation. Now, what we didn't have, it's a simulation of the environment of the cafeteria at which we wanted the robot to work. Then, what we did was to create a simulation of the environment, and I'm going to show you how to, wait. So how does it look, the simulation that we built? So this is a simulation of the space that we simulated. This is the cafeteria, and then it contains the people. The two guys who created this, they took a lot of time into the details. Let me just tell you that the whole product was constructed in only 3 months. So including this simulation, including learning ROS. Of course, they used the Robotic Night Academy to learn ROS very, very fast. So they were able afterwards to create all these kind of things. And so, well, so let me go a little bit further. So you get the different areas of the cafeteria, different tables, elements, even decorations, because we want it to look very, very real. And as you can see, it contains a whole space of the cafeteria. So that's for the simulation of the environment. And let me see if there is any question there. Okay, so here, can be handled the processing? It's a question by Mrudul Katla. And I suppose that you mean if can Raspberry Pi handle the processing? Well, it depends on what you want to do. Raspberry Pi can process a lot of things. So yeah, I would suggest you that you try it. Unless you don't want to do something very heavy like in perception, deep learning, or something like that, I think it's very likely that your project will work with a Raspberry Pi. Vijayashri, he says, what is the likely budget a person building this kind of robot should have? Good question. For that kind of robot, okay, for that kind of robot specifically, it's around 2,000, 2,500 euros for this kind of robot, more or less. But it depends on your product, of course. Then Fontina, he says, can we detect things like humans, landmark, traffic signs using ROS for self-driving car project? Are there any packages available for that? Yes, it exists. You can do that, and there are packages there. I recommend you to look at a project that is called, what's the name of this? Miguel, can you help me with this? What's the name of this project about self-driving cars that contains all the packages? Yes, super complete by the Japanese guys. It's okay. Yeah, that package
the traffic
for that it contains traffic lights detection. Well, there is a package. I will write it down afterwards. I don't remember now. It's massive. You have everything done there, and you can use it. So you can use, and it's based on ROS. I will check that later. Okay. Miguel, my colleague, he says it's AutoWare. AutoWare. I will put it anyway, the link there beneath. Another question, how do you secure the communication between the robot and the web app? Okay, you cannot secure. You have to have the network closed. So at present, ROS doesn't allow to have security. So you have to be sure that nobody can get into that network, into that Wi-Fi network. What we did was that the robot was creating its own Wi-Fi that nobody else can use it. So only the iPad was synchronized with the robot, and that's all. Jorge is asking, is there a ROS bridge for Android? Well, yes. Actually, well, it's not that ROS bridge runs in Android, but that the Android can communicate with the ROS bridge. That is different. So the ROS bridge can run in another place. I think that there is no ROS bridge for Android. I'm not 100% sure, okay? But what I'm sure is that Android can communicate with the ROS bridge using a WebSocket, and that's all. Viorel, position of the table is obtained just by using odometry? No, it's using SLAM techniques. So the robot is localized using a map and localization, particle filters, and everything. But the good news is that it's already provided by ROS. Then another question is, the simulation is done in RDS? Yes, it is. You are going to see now some more details about that. Then Forn says, is there tutorials about creating those simulations in Robot Ignite Academy? Not at present. We don't have any tutorial about creating the simulations. I'm going to show you a video about how to create the objects for the simulations. So I'm going to provide you this link and show you afterwards. Subham, what is the internet protocol for bridging? I'm sorry, I don't know this question, Subham. I'm sorry. I don't know, but I'm sure that it's explained. If you go to the wiki of ROS and then you look for the ROS bridge, you will see the description of there. And also at the end, you can go to the Git of that project and get the information. Okay, so let's continue with this because we have to finish. And so you have seen now the simulation of the environment. So, and the simulation of the robot. You should create this also and start developing on there. And that's exactly what we did. In order to build this simulation, what we did is first to get a map of the environment, of the real environment. We took the real environment. Maybe in your case, it's not necessary to have such detail, but we wanted to show very professional. So we took the real map of the environment, and then we used this tool from Gazebo that allows you to build in editor to build the walls. So we build the walls, and then finally we use this video that I'm going to show you, and I'm going to put this beneath the as a link beneath this presentation, this webinar, that says how you can create all the materials, all the elements that you need for your simulation. And this is a tutorial step by step. Basically, it uses 3D warehouse to get the models that you are looking for. So as you can see here, there are many, 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 many. So as many as you can think of. So you go there, look for the model that you want to use. Then you download it. And finally, once you have downloaded, well, you have to open with a SketchUp in order to modify a little bit some parameters. Sometimes it's not even necessary. We explain here step by step how to do this. And then once you have this, you export as a Collada file. And then sometimes you need to open with Blender. And you open with Blender, and then you import from Blender. And finally, you have to do some small modifications, like sometimes it's not necessary. It depends on the model who has done it. But sometimes the center of masses is not correct. So you can correct it. Here, using Blender, we explain how to do it. And finally, you have to create the model for Gazebo, some files that use this model. And here, we explain you how to. So I'm not going to explain everything here, but I'm putting the link so you can follow this video afterwards. It's a step by step. And at the end, let me go further. Once you have created all the files and calculated the inertia, etc., then you can import it at Gazebo, as you can see. And you have the model there in Gazebo. Okay, great. So another thing that I have explained you about how to create a robot environment for your robot. Then, what's next? So then, in this case, as you can see, we put all the simulation inside the ROS Development Studio, and we use it as a platform for developing the application. And the next thing that we did was to test the navigation. So we started the ROS navigation stack with the Turtlebot. It's quite easy. If you follow the tutorials in ROS, you can find it. If you do it through the Robotic Night Academy, then it's even easier because it's a step-by-step with many, many indications and practical examples. So the only thing is that we were making the robot navigate using the ROS navigation in the simulation. And then let me show you this video that is an adaptation with the table number. So once we have the simulation running, the robot in the simulation, the navigation running, once we have all that, then we need to create this small adapter. That is here in this video, you can see on the left-hand side, the simulation in the RDS. Here, on the right-hand side, you can see the RVs on the RDS. And that is showing the map, and the location of the robot here is here. That corresponds to here in the simulation. And here you can see our small program that is the one that receives from a topic a name of a table, a number of a table. And then it converts this number of table into a navigation goal. So if I start this, And everything here is tested on the ROS Development Studio. You can do the same thing in your local computer, okay? You don't need to use ROS Development Studio. It's just a suggestion. In this case, we have put here table number 2, and then this has been converted into a goal that is sending the robot to table number 2. And you can see that it's moving here in the simulation and here in the navigation. So we had to build this goal, Python goal node, ROS node, in order to achieve this translation. Then the ROS bridge, what it does is to get the number of the table from the web and then write down into the topic that we are writing here, the number 2. So the ROS bridge would write a number 2 also. Okay, so basically that's the adaptation software that we built. Is very simple. As you can see, it's very simple software. And now, let me show you the web page with navigation control. So that's also some software that we have to build. If you remember, in the previous slides, let me show you. Okay, here is kind of stuck, the slide, just a second. Yes, so let's go on, move. So maybe I should do it like this. No, here. Yeah, so here you can see we have 2 adaptation parts. First, the node that connects ROS to the bridge and gets the number of the table and converts into a goal for ROS navigation. And now the web page that shows the tables and allows selection. So those are the only 2 things that we have done. So if I press here, sorry, it's not there, is here. Web page navigation control. So here you can see this is a web page that contains on the left-hand side is the web page that contains the number of the tables, okay, as they will be presented in the iPad. So this is exactly the interface that we presented on the iPad. At this point in time, we were only testing on the computer. So that's why you see here the browser that contains the web page. But it's exactly the same that will be presented in the iPad because it's just a web page. On the other side, we have the ROS Development Studio with the simulation and the code, the same program here. You cannot see. Let me put it bigger. Maybe you can see better, a little bit better. Then here you have the simulation, and here you have the program that I have shown you before. Now the person is going to click here in a table. I don't remember which one. And the robot that is located here, in the simulation, is going to start to move using this program. Same. So I'm going to start the video. Then somebody has pressed. Is not yet. Okay. Oh, yes. So it has pressed at some point in time here. So a navigation goal has been sent, and then the robot is starting to move here in the simulation and more or less shown in the web page. Yes, the coordination between this and this requires a little trick of mathematics, and sometimes doesn't work so well, but that is okay. So you can see the reason how it works. Okay, great. So, and basically that's it for this second part. So what you should take from this second part is that you have to test everything in the simulation. Everything has to be developed in the simulator and make it work there. You have seen how, some tricks about how to build this simulation, how to build all the elements that you would need, some ideas about simulating on the cloud so you can avoid installing your computer. But those are just small things. The important thing is that you test everything on the simulation first, so you can be sure that your product is going to work or has some chances to work before you spend a dime on this. Okay, so that's the end of this presentation. Then for this part is your homework. As in the previous webinar, you have some homework, and your homework is to identify the exact parts that you are going to buy, that you will buy for your product, and then to create the simulation for your robot. The simulation of the robot, if it doesn't exist, then you have to create it. And of course, the simulation of the environment at which the robot will work. If you don't have this, and you think that's a lot of work, please check the internet. The internet is plenty of simulations already available. Check the ROS Development Studio for which simulations there already exist there. And send me your simulations, your list of components. Send me to this email whenever you have it, so I can test it. And if you are inside the RDS, the ROS Development Studio, you can share with this user directly your simulation, and then I will receive it inside the RDS also. So it's up to you, okay? So send me your homework, and I will have a look and provide you some feedback. Just before we go to the questions, I would like to point you that we are creating the ROS Development Conference, that it's starting on July 7th and 8th, and it's an online conference for developers where anybody that attends this conference can stay at home. You don't have to travel to any place. Just stay at home and then connect to the conference and practice at the same time as the person that is explaining. So the speakers will be explaining practical things, how to do something, how to do this, how to do that. And he will be showing how to, and you will have to do it using the ROS Development Studio. So you will have to install nothing, and you will have an account, full account, for whatever you need for that. So that's all for today. I'll be happy to answer some questions if you have it on the chat. So I'm going to connect to the chat, and let's see what the audience is requesting. Let's see. Here, is there any tutorials? Okay, no. What's the internet protocol? Sorry. Tell about ROS MATLAB interface. Okay, Mano, I don't know about the ROS MATLAB interface, but I presume that is something that allows you to execute code in MATLAB and then send the results to the ROS and vice versa. So you can get a very powerful computation on MATLAB that connects to the topics for getting the information that it needs in order to compute, and then produces the results in other topics. I presume that is something like that. Okay, Jorge Vargas, very impressive. Thank you, Jorge. Roberto, what framework can be used for building a fast web page interface? Okay. What framework? I don't know. For example, a fast web page interface is WordPress. I would say that's very, very fast. You have everything there. But I don't know. We built our frameworks using HTML5, CSS, and when we have our applications on the webs are built using Django. Or another very famous interface is Ruby, but they are not fast. I mean, they are fast for complex things, but in case that you want to build this fast, you would need to do some HTML5 or something. Phone. How to pay using Visa or MasterCard for the conference because PayPal isn't available in my country? Okay, good question, Phone. So sorry, it's not available yet, but we are going to put this in the next week. So you will be able to pay with Visa and MasterCard. Please stay tuned to this channel, and you will know when it's available. Hi, Dao, thank you very much. Hi. Then Abimanju says, which software should I use to design the simulator environment? Then the software is the simulator, is the Gazebo simulator. So you have to learn how to create simulations in Gazebo. And then Viral says, for simulation, the robot can be done in SolidWorks or CATIA and then saved as a file for Blender. Yes, actually, we have a very super good tutorial that teaches you how to create a robot, a model in SolidWorks, and then transfer that with controllers, with everything to the Gazebo simulation. So you can do it directly from SolidWorks into Gazebo. And I'm going to show you this here. I don't know where it is. Okay, so it's not here, but okay, so I will look for that and put it beneath. I'm taking notes, okay? So I'm going to put this SolidWorks tutorial to Gazebo, so you can design your stuff in SolidWorks and then export directly to Gazebo. Okay, Fawn, thank you. Viral, cool. Wow, cool, thank you. Very good. So that's all for today. Please don't forget to send me your homework, and let's talk on the next webinar next Wednesday, where we are going to show you how to transfer this to the real robot. So the next webinar will be about the real robot, the real product. So let's wait until there. I'll be looking at my email for your homework, okay? So thank you very much, and subscribe to our channel. Give us a thumb up if you like it, and see you next week.